Let's take a look at acceleration problem 19 in OpenStax College Physics. So we have here, assume that an intercontinental ballistic missile goes from rest to a suborbital speed of 6.50 km per second in 60 seconds. The actual speed, of course, we don't know the actual time and speed, but we are assuming here that it is 60 seconds. Okay, what is its average acceleration in meters per second squared and in multiples of g? So we can just think of this as, there's a missile. So the missile may somewhere here, start from here. Okay, that might be your missile, the ballistic missile, and it's somehow accelerating. Okay, it's speeding up until it reaches here, somewhere here, and its speed here is supposed to be 6.50 kilometer per second. Okay, that is its speed there at that point. Now, what is the acceleration? Again, the acceleration is very simple to compute once you know the formula well. Acceleration is just change in velocity, with respect to time, or simply v final minus v initial over t. Now in this case, we know v final well. It's 6.50 kilometer per second. However, we don't know, we are not given with the velocity initial, but careful analysis of the problem reveals that, of course, here one can see that the missile here is not yet moving, so it must be moving at zero, right? At a speed of zero. I hope that that is not that hard to see. So it will be minus zero divided by that time. Of course, here it's given to be 60 seconds. 60 seconds. So the acceleration will for this case will be 6.50 divided by 60. Okay, so it will be 0.1083. 0.1083. But note here, be very careful that the unit here will be kilometer per second squared. Okay, kilometer, and then there are 2 per second, so kilometer per second squared. And note that we are not being asked for that. We are asked for in terms of meters per second squared. So how do we convert that? Well, it will just be straightforward. A will be equal to 0.1083 kilometer per second squared. Just multiply by the conversion, converting kilometer to meter. So what is that? 1 kilometer is 1,000 meter, equal to, so then it will just be moving by 3, right? So it will be what? 108.3 meter per second squared. So this is the acceleration of your projectile or ballistic missile during that launching period of 60 seconds. Now, if we'll solve in terms of multiples of g, so what do you mean by multiples of g? So that a is the same as 108.3 meters per second squared times, and we know that 1g, okay, one acceleration due to gravity is just 9.80 meters per second squared. So this thing will just be times 100. Okay, that's, no. It's 108.3 divide 9.80. Okay, and that's giving me 11.05 g, or around 11 times as fast, meaning 11 times as big as the acceleration due to gravity. Again, acceleration has a corresponding force, because according to Newton's law of motion, which we will be learning later, that when an object is accelerating, it will only accelerate if there is a net force exerted onto it. Okay? Hope you get something out of that. Thank you.